At this time, I would like to explain section 10.7. Section 10.7 begins on page number 750. It involves three theorems. The first theorem is Theorem 1015. Theorem 1015 involves the intersection of two chords. If two chords intersect inside a circle, then the product of the parts are equal. In this case, looking at my picture here, we have a segment that goes from D to E and A to C. This theorem says, therefore, that the segment length AB multiplied by the segment length BC equals the segment length DB multiplied by the segment length BE. Let's apply that to a problem. Problem number 1, page number 753. RV times VT equals UV times VS. 4 times 4 is 8 times X. Solve for X. Problem number 2, VP times PX equals YP times PX. X plus 3 distributed over X plus 4, use the FOIL method, equals X times X plus 9, distribute X over X plus 9. All right, the next theorem involves two secants. Secants are lines that intersect outside of the circle. In this case, AC intersects AE. AC is made of two parts, an external part AB and the total AC. And that's going to be equal to, in other words, AB times AC, the total equals AD times the total AE. AB times AC is equal to the external part AD times total AE. Let's imagine the external part here is 2. 2 times the total of 6 is equal to the external part 2.5 times the total of 2.5 plus 2.3 or 4.8. You get 12. 2 times 6 is 12. 2.5 times 4.8 is 12. External times total equals external times total. Let's apply that to problem number 4. AC times AE equals AB times AD. In other words, 7.5 times the sum of 7.5 and 4.5, which is 12. 7.5 times 12 equals 5 times 5 plus x. Distribute the 5 over the 5 plus x. 25 plus 5x equals 7.5 times 12, and solve that. One more example here. Problem number 10. 4 times the total 12, AB times AC, equals 3 times the total 3 plus x. The third theorem involves a tangent and a secant. The law says that the tangent squared is equal to the external part times the total. In other words, AD squared equals AB multiplied by the total AC. 6 times 6 is 3 times 12. Problem number 3 is an example of this. Problem number 3, 6 times 6, that is JK, multiplied by itself, equals HJ, the external, multiplied by the total, which is x plus 4. 6 times 6 is 4 times x plus 4. Distribute the 4 over the x plus 4. Another problem is problem 12. 9 times 9 is equal to 5 times 5 plus x. Distribute the 5 over the 5 plus x. Some of the problems you'll be doing today involve both laws, like problems numbers 18 through 21. All right. For 18, or actually let's look at 19. You're first going to have to solve for a using the 10. 10 times 10 is 4 times the total, which is 4 plus 6 times a, which is 10 plus a. So 10 squared equals 4 times, parentheses, 10 plus a. Solve that for a. Then use it. Once you know it, you can say 6 times its value equals 8 times b, which is the first theorem that we learned in this section. A number of the problems we're dealing with today cannot be solved simply because they have a square. And so I'd like to explain the method of solving equations that have a square. This is explained for you on page 753. It's called the quadratic formula, which I'm now going to demonstrate using this equation right here. Let's imagine I have the equation x squared plus 12x minus 144 equals 0. In fact, this is one of the problems you're going to be doing today, and you have to solve it. So let's talk about how to solve it. Now, first of all, remember, if there's nothing written in front of the x squared, I understand that it is 1. So x squared is the same as 1x squared, and that's why I put a dotted line here. If this was just x squared, it's actually 1x squared. All right. So the first thing for us to remember is if we have an equation, the first coefficient is given the value a. In this case, 1x squared, a has the value of 1. B is the second coefficient, and it has the value of 12. And c is our third coefficient with a value of a negative 144. Now, the question we're trying to solve is, what is x? What value of x would you square, multiply by 12, and subtract 144 and get 0? What is the factor for this, or what are the factors for this equation? All right, the law says that the roots or the factors of this equation equal the negative of the second coefficient, the negative of b, plus or minus the square root of that coefficient squared, b squared, minus 4 times the first coefficient, a, multiplied by the last coefficient, c, in this case negative 144, divided by 2 times the first coefficient, a. And I apologize that I cannot show you examples on the chalkboard, but try to listen carefully and then go back to page 753 and look at the example 4 to help solving equations to the second degree, but I'm trying to give an example here for you. So the question is, what values of x would you plug into this equation such that when you did so, you would get 0? What are the roots of the equation? Okay, so x is negative b. In this case, again, we see that b is 12. So we put in the equation x is negative 12 plus or minus the square root of b squared. Well, that's 12 squared. Minus 4 times a, which is the first coefficient. Right here, 4 times 1. Multiplied by the last coefficient, c, right here. That went right there. Negative 144. Okay, we always over 2 times a, which is 2 times 1. Now, whenever we solve an equation like this, we always take care of the root first, whatever's underneath the square root symbol. Okay, so we have to solve whatever's underneath the square root symbol first. So we have 12 squared, that's 144, minus 4 times 1 times negative 144. When you do the math, you will get the square root of 720. The reason being you have a double negative here, negative 4 times 1 times negative 144 will be a positive number. That positive number added to 144, which is 12 squared, gives you 720. All right, so check that out, see if you can get 720. So this is now negative 12 plus or minus the square root of 720 over 2. Okay, let's talk about this a moment. Now, we are dealing with figures that have real lengths. And you agree that you can't have a negative length, right? You can't go negative 3 miles. That's not possible. So you have to think to yourself, what is negative 12 plus or minus the square root of 720? Well, if you take the square root of 720, you get 26.8. And would it be possible for this problem to have one of its roots being negative 12 minus 26.8? Well, absolutely not, because then you would have a negative length. So we're going to remove this minus. In some cases, it stays, depends on what's underneath that root symbol. But in this case, it's not possible for you to take negative 12 minus the square root of 720. That'd be negative 12 minus 26.8. All right, that would be approximately negative 38 over 2, negative 17. You can't have a segment negative 17 units long. So I'm going to eliminate that particular root. I'm just going to use the positive root, but this depends on the problem. In some problems, you may have 2 roots. I'm just looking here to see if you have 2 today. It looks like in most cases you will have just 1. All right, so negative 12 plus 26.8 over 2. If you do the math, you're going to get an answer of 7.4. 7.4. Okay, so this is your assignment for today, problems 1 through 21. Again, you are free to call me if you are struggling. This is a challenging assignment today, and you may call me at 492-2823. Thank you.